Welcome to the 4.7 Rational Roots Theorem notes. One thing I'm just going to get off right off the bat is the equation for this first example is actually incorrect. So we're going to go ahead and cross it out and focus on the ones without a graph. So essentially what's happening here is there is a way you can find all of the possible rational zeros to an equation just by using two of the numbers, using what's called the rational roots theorem. So the rational roots theorem essentially says that all possible rational solutions come in the form factors of the constant over factors of the leading coefficient. Now the constant is the one without an x, leading coefficient, as leading tends to mean, is the one in front. So for example, on this very first problem that I didn't cross out, all of your possible zeros, I'm going to go ahead and write this over here, so possible zeros, are going to be factors of the constant 20, so 1 times 20, 2 times 10, or 4 times 5. Those are all factors of the constant, over factors of the leading coefficient, which is just 1. So that's just 1. And I should include that these are always going to be also positive or negative, if you want to add that up here too. So this means my possible zeros are like 1 and negative 1, 2 and negative 2, 4 and negative 4, 5 and negative 5, 10 and negative 10, and 20 and negative 20. And basically what we're going to do today is test these using synthetic division and use that answer to synthetic division to factor and find the rest of them. Okay, and just a reminder that if the polynomial has a degree of n, then that's how many roots it has. So x to the third is always going to have 3 roots. X to the fourth is always going to have 4 roots. Okay, so now that we know that those are my possible zeros, what I'm going to do down here is go ahead and draw a box. I recommend you do kind of the same thing, and I'm going to write zeros down here. And we're only going to put ones in this box that are actual zeros. And I'm just going to test them in the same order I listed them in up top so that it just follows an order for you. So I would start with like the number 1, put it in the corner of synthetic division, list my coefficients and constants, and drop the first number down. Then every number that goes down there you're going to multiply by the number in the box. So 1 times 1, is 1. Negative 8 plus 1 is negative 7. Negative 7 times 1 is negative 7. Add that to the 11, you get 4. Multiply that by the 1, you get 4. And I already know that when I add that to the 20, I'm not going to get 0. So I'm going to cross it out and move on to the next one. Remember that your goal for finding zeros is that this equals 0 at the end. Drop the first one down. 1 times negative 1 is negative 1. Add that to the negative 8, you get negative 9. Multiply that by the negative 1, you get positive 9. Add that to the 11 and you get 20. Thank goodness, because multiply that by the negative 1, you get negative 20, and we get the 0 that we wanted to. So that is one of the zeros. I'm going to go ahead and list negative 1 over here, and I'm going to find the rest of them by factoring the quotient, which is going to be 1x squared minus 9x plus 20. So basically I need to find the two numbers that multiply to 20 and add to negative 9, which is going to be negative 4 and 5. So my factors are x minus 4 and x minus 5. And just a reminder that when you're finding the zeros, you want this to equal 0. So basically I have to solve the equation x minus 4 equals 0 and the equation x minus 5 equals 0. Which just means I add 4 and 5 to both sides, and I get answers of 4 and 5. So my zeros are -1, 4, and 5. Now, I just want to take a second to point out that -1, 4, and 5 were all on that list. All of the others are just possibilities that weren't actual zeros. And that's the thing about finding a list of possible zeros, is not all of them work. You have to weed out the ones that do with synthetic division. Then, once you've done the synthetic division, you take that up here and you factor it to find the other two. Alright, let's try another one. So I'm going to come over here, I'm going to write the word possible, and kind of draw the same box I did last time. And my constant this time is actually 2. So that's just, factors are going to be 1 and 2 over factors of 1. So I have 1, -1, 2, and -2. Which is much easier. There's only 4 possibilities this time. So it shouldn't be too hard to weed out which ones work. And then I'm going to draw that box for my actual zeros. Okay, so I'm going to start with, I'm going to start with 1 and -1. So here's 1. I'm going to get 1x squared, 4x, 1x cubed, 4x squared, 5x, and 2. So I copied all my coefficients and constant. Drop the first one down, multiply that by 1, I get 1. Add it to the 4, I get 5. Multiply that by the 1, get 5. Add that to the other 5, I get 10. And 10 times 1 is 2. 10 times 1 is 10. Add that to the 2, I'm definitely not going to get 0. So I'm going to cross it out and move on to -1 instead. Drop the first one down. This time I'm multiplying it by -1, which is -1. Add that to the 4 and I get 3. Multiply that by the -1 and I get -3. Add it to the 5 and I get 2. And multiply by the -1 and I get -2, which actually does give me 0. So -1 is one of my zeros. I'm going to go ahead and bring that quotient up here and factor it. It will be x squared plus 3x plus 2. So I need two numbers that multiply to 2 and add to 3. I'm really limited on my options because it's just 1 and 2. I want to set that equal to 0, which means my answers are going to be from the equations x plus 1 equals 0 and x plus 2 equals 0. So I get -1 and -2. Now, instead of writing -1 again over on my list, because you'll notice that I actually got it not once, but twice. So I'm going to write double next to it, and then I'm going to write -2, because it was my other one. Now, what that word double means is it counts as 2, like we talked about with the graphs. And you'll notice that I still remained with only numbers that were on my list. Now, it is possible that they're not on your list, and I'll explain what happens with that in the next problem. Alright, this is going to be our last one. I'm going to go ahead and draw my box, write possible at the top. This is essentially just giving me a list of ones to check. Factors of the constant, which is 2, so 1 and 2, over factors of the first number, leading coefficient, which is 2, so also 1 and 2. Now, what that means is I'm going to have 4 possibilities here. 1 divided by 1, 2 divided by 1, which is 1 and 2. So 1, negative 1, 2, negative 2. Then I'm also going to have to divide them by 2. So 1/2 and 2/2. 1/2, negative 1/2. And I'm not going to write 2/2 on my list because that's just 1. So I'm going to leave it off of my list because I don't want to write any repeats and make myself think that there's more numbers to check than there actually are. And I'm just going to start in order and try 1, and then I'm going to try negative 1, and then I'm going to try 2, then I'm going to try negative 2, and hopefully by that point I will have found 1, and I won't actually need to use the fraction ones. Okay, I'm going to zoom in a little bit on this one. 1. Then, as I'm listing my coefficients and constants, I notice that this one goes straight from x cubed to x to the first. So it's missing x squared in the middle, which means I need a 0 placeholder right here. So my coefficients and constants are actually going to be 2, 3, 0, 3, negative 2. If you don't have that 0 placeholder in there, none of these will work because they won't be the right numbers. Then I drop the first one down, that's 2. Multiply it by the 1, that's 2. Add that to the 3, it gives me 5. Times 1 is 5. Add it to 0, you get 5 still. Times 1 is still 5. Add it together, that gives you 8. Times 1 is 8, and that's definitely not 0. So I'm going to move on and try negative 1. 2, 3, 0, 3, negative 2. Drop the first one down. Times negative 1 is negative 2. Plus 3 is 1. Times negative 1 is negative 1. 0 minus 1 is negative 1. Negative 1 times negative 1 is 1. Plus 3 is 4. 4 times negative 1 is negative 4, and I don't get 0 again. So this time I've got to keep going. Now I'm going to try 2. Drop the 2 down. 2 times 2 is 4. Add that to the 3, I get 7. Times 2 is 14. Add that to the 0, I get 14. Times 2 is 28. Add that to the 3, I get 31. Times 2 is 62. That's definitely not going to be 0. So I've got to keep going this time. Hopefully negative 2 will work so I can avoid the fractions. Otherwise I'm going to have to use 1/2 and negative 1/2 inside of this problem. So same setup, I'm just changing the number in the box to negative 2 this time. Drop the 2 down. 2 times negative 2 is negative 4. Plus 3 is negative 1. Negative 1 times negative 2 is 2. Plus 0 is 2. 2 times negative 2 is negative 4. Plus 3 is negative 1. Negative 2 times negative 1 is positive 2, which, thank goodness, gives me 0 finally. So negative 2 is one of my zeros that works. And that's what it looks like sometimes if it takes a while, guys. Negative 2 is the only one that worked. It could have been 1/2, negative 1/2. We'll find out when we find the rest of them. Now, when I go to write the quotient here, you'll notice that this time there are 4 numbers besides the remainder. So this is going to be 2x cubed, negative 1x squared, 2x, and negative 1. And because there are 4 terms, and I'll write this over to the side, whenever you see 4 terms and you're trying to factor, you have to group. Which means we're going to split it down the middle. I'm going to do a greatest common factor of the 2 terms on the left. I can take out an x squared, which leaves me with 2x minus 1. And on the right, I actually can't divide those by anything, so I'm going to put a 1 out front, and that also leaves me with 2x minus 1. So my factors are 2x minus 1 and x squared plus 1. And I want to set each one of those equal to 0. So 2x minus 1 equals 0, and x squared plus 1 equals 0. If I add the 1 to the other side, I get 2x equals 1, and I'm going to have to divide by 2, so it's 1/2, which is actually this one. Then, with the other one, I would subtract the 1 to the other side. And what do we do to get rid of a squared? We square root, ladies and gentlemen. And the square root of -1, first of all, when you square root, you have to do a plus minus. And the square root of -1 is I. So my zeros are -2, 1/2, I, and -I. Or you can just simply write that as plus or minus I. I don't care. The reason why I wrote it as 2 is because I can clearly see that I have 1, 2, 3, 4 zeros. Because it was x to the 4th. Now, you might be like, but those didn't show up because i's are not rational zeros. So any ones that are square roots or i's won't show up on this list. That's why we actually need the list. That and the fact that these can't be factored from the get-go. Okay? Go ahead and try the assignment and let me know if you have any questions.